If f of x is sine x cos x, what we got to do then is we got to evaluate what the first derivative is. Upon completion of the first derivative, we got to replace x with pi over 4. You need to automatically, straight away, you go to your setup and you got to put your calculator in radian modes, or the same thing as theta equals 45 degrees or x equals 45 degrees, whichever one you want to do, because pi over 4 is 45 degrees. U and v. U equals sine x, du dx equals cos x. V equals cos x, dv dx equals minus sine x. Next to the product rule, Patrick. dy dx equals v times du, u times dv dx plus v times du dx. And what we get next, guys, is this. We're going to get sine x times cos x. Yes, Simon.
How do you know what you...
The common question is, why wouldn't you split it down here? Well, the truth is the sine and the x belong together. Vice versa, the other way around, you wouldn't split it down here because the cos has to have an angle joined with it. So the only explanation for splitting it is dead centered. Now, it's going to be sine x multiplied by the v dx, which is minus sine x. And then we're going to have plus cos x for v, and then another cos x for u. Now, when we put this in, what we're going to get is minus sine squared x plus cos squared x, and that's equal to cos squared x minus sine squared x. Now, oddly enough, just for your own sake, there is a function for this, isn't there? It's actually cos 2x, isn't it? If you look up your tables, it's actually cos 2x. So you don't actually have to go that far, guys. Are you asking?
What question is this?
This is question 22. Now, guys, you could have put in the pi over 4 right away if you wanted, okay? And the pi over 4, you can say minus sine squared. So the way I have to do this is minus sine. Yeah, you can't do it that way, so you have to do it in brackets, I'm afraid, okay? So we got to do bracket minus sine pi over 4. Now, it's actually pretty faster just to keep it in degrees mode. But anyways, close bracket, another bracket, squared. Okay, now, squared theta. Now, there's a problem there as well. See the minus? The minus doesn't belong to the sine squared theta. So you actually got to move the minus outside the bracket. Okay, so it's a call you have to make there yourself. It's going to be minus 1 times sine squared pi over 4 there, okay? And then on the other one, it's going to be plus cos squared. So once again, open up your bracket, cos pi over 4. Probably much easier just to do 45 degrees. Close it again, square it, and then our answer is 0, which is correct. Now, if you did it my way, you could have just did it as cos 2 times pi over 4. What's 2 times pi over 4? Pi over 2. And cos pi over 2 is in your tables as 0 as well. So breaking it down, when I broke it down, it made the calculator part a lot easier. But then again, you're risking an error as well. Okay, that's that one done. Okay. So that's that one done up there. Everyone wants to take it down. Okay, next one we're going to do is question 22, correct? So 22.
Just do 23.
Oh, sorry, question 23. Excuse me. Okay, so 23. So that's 22 there, and now we're on 23. Now, for 23, what we're going to do is if y equals cos 2x and plus 2 sine x, we got to differentiate and replace x with pi over 6. Now, another way of writing this question would be this. I could write this question like this. I'm just going to show you 2 questions that mean the same thing. This is as an extra, just a bit of extra learning. If I wrote this down, that actually means the exact same. Question. You got it? First derivative, replace x with pi over 6. We're going to do it with 30 degrees this time because we found out putting those extra fraction buttons in, it's not exactly helpful to speed in a test. So we can just go back to degrees mode and just use 30 degrees instead of pi over 6. Makes things faster. Okay guys, now that that's done, what we're going to do is we're going to differentiate this, okay? So when we differentiate, we're going to differentiate cos 2x. And what happens to cos when you differentiate it? Turns to minus sine. Minus something sine 2x. We forgot to differentiate the brackets, which puts a 2 in here. Then it's going to be 2 sine x. The 2 goes directly down. It's unaffected by the derivative. And then sine x, we differentiate it into cos x. Replace everything with 30, so it's going to be minus 2 sine 60 plus 2 cos 30. Put it into the calculator, and what we'll get is 0. Answer for this one is 0. Okay, that was a pretty not too bad a question. Okay, it was nice and short actually.
So I thought you don't do anything to the angle.
Sorry?
I don't do anything to the angle.
I didn't. The angle remained the same. Do you see it here?
Yeah.
But I was told to replace x with pi over 6, and pi over 6 is 30 degrees. So I just replaced x with 30 degrees as well. So I didn't actually change it. I already differentiated. That's the answer. The differentiation part is underlined in red, in the red box. And then, once I got the differentiated part, then I replaced x with 30. Has nothing to do with the actual differentiation. Okay? Alright guys, Simon?
What do you replace x with?
Now, did I do this yesterday?
Yeah.
I did.
Yeah, you did.
Did. Okay, done already.